Hey everybody, we are at 3.4 today, and we're going to talk about multiplying rational numbers, okay? We've talked about adding rational numbers and subtracting rational numbers. We are going to talk about multiplying now. So you guys know what multiplying is, and you know what rationals are. So let's just get right into some examples here, okay? If I had a negative number times another negative number, okay? I'm not sure if you guys know how to deal with that. The nice thing is that we have a little chart up here, multiplying and dividing. So what does this little chart tell us? Well, it helps us remember what the answer will be, or the product. So the answer when multiplying is called the product. Let me just write that down. Product is the answer from multiplying. And so what sign will the product be if we have, in this example, a negative number times a negative number? Well, you probably know this one. It's right here in this little row. It yields a positive number. Now that might seem a little bit weird, but two negatives, when multiplied together, make a positive. Kind of like when you subtract a negative, those two negatives right beside each other, those two negatives turn into adding, remember? Minus a negative turns into adding. Same sort of thing, a negative times a negative makes a positive. Now the nice way to remember this, I think this is the way I like to remember this, is that whenever you have the same signs that you're multiplying together, the answer is always positive, whether it's plus and plus, and positive, or negative and negative. The other thing to remember then is when the signs are opposite, you always have a negative solution or product. So that's pretty easy to remember, okay? Negative times a negative is a positive. All right, so how we handle the other multiplication of, like, let's say numbers, regular old whole numbers, or these are integers, then it's just the same as multiplying 6 times 3, like, you know what that is, right? It's 18. So negative times a negative is a positive answer, and 6 times 3 is 18, so your result is positive 18 here. And yeah, you don't have to write the positive, the plus little sign there. You can just leave it as just 18. Now the signs here in B are different, you see. There's no sign here, and let me just zoom in there. There's no sign on the 20, so that's understood to be positive. So if the signs are truly different here, positive and negative, my answer is going to be negative. And then you just focus on the numbers. 20 times 2 is 40. So that's the answer when you multiply a positive 20 times a negative 2. What about decimals? Well, the nice thing is that when you multiply decimals, all the same rules hold true. You just have to remember how the signs work. So these signs are different, negative, positive. So the answer is negative. We have a negative result. Okay? So if we're going to multiply these, let's practice multiplying just by hand again here. So 1.5 times 1.8, we're going to multiply those up. So what you do is you take the 8 and you multiply by 5 and you get 40. So you put the 0 down there, you put the 4 up here. 8 times 1 is 8, plus 4 is 12, and you put 12 there. Now you move over to the next number on this bottom row here, this bottom number, the next digit I should say in the bottom number, and you multiply the same thing. So 1 times 5 is 5, and you start over here, right, in line with this number. So you just put the 5 there, and you put the 1 there. You forget about that 4 now. And then you add these up, so you've got 0, and you've got a 7, and then you've got a 2. And the last thing to do is to make sure that you count all the decimal places. So I have 1 decimal place here and 1 decimal place here. That makes 2 decimal places in my number. So 1.8 times 1.5 is 2.7, and we have to remember that's going to be negative. Okay? And yes, you could get out your trusty calculator. For a lot of these questions like B, we're going to have to do that. That's no problem. You can use your calculator for the most part here in this chapter. All right, so what happens then if we have a negative 2.6 times a negative 3.25? Well, this answer, first of all, is going to be positive. That's great. And then let's get some practice with our calculator. Now, you have to be careful, okay, on your calculator. Let me turn this thing on first. Oh, clear, clear. So on your calculator, your calculator might not look just like this one, but you'll have a negative button and a minus button. They'll probably be separate. Or you could have like a plus minus. It could look like this, plus minus or something like that. Or it could be, you know, a function above another button, okay? The whole point is that when you're multiplying these, you want to use the negative sign, not the minus sign, not the operation. So I'm going to write negative 2.6 times, there's my multiplication, negative 3.25. All right, looks good. And so the answer is positive. The calculator confirms that, and it's 8.45. 8.45. And if we were to multiply this by hand, that should have been the number you got too. Okay, so when the signs are the same, the answer is always positive. All right, multiplying fractions. Well, the nice thing about multiplying fractions is it's a lot easier than adding or subtracting because you don't need to first get a common denominator. So I'm just going to type that out here. It's not in these notes here, but I'm going to type that out. Let's see if I can do that right here. You do not need a common denominator. All right, you don't need a common denominator to multiply. That's pretty cool. It's a little less work, isn't it? Now there will be some simplification that we'll do when we multiply fractions, and I'll show you that in a bit. But the nice thing about this is that with any two fractions or rationals like this that you multiply, you just simply multiply the numerator of one times the numerator of the other one, and you can write that as one number on the top, then on the numerator position. So watch this. Negative, I'm going to treat this negative as a negative number, okay? Keep it with the numerator is usually a really good idea. So negative 2 times positive 3 is going to be negative 6. You see that? And then 5 times 8. So once again, I did negative 2 times 3. And now on the bottom, I'm going to do 5 times 8. Don't use the negative twice. Okay, only use the negative once. And this is going to be 40. Okay, and I just did denominator times denominator. And it's as simple as that, except for the fact that we do want to simplify our answer. So you look at this fraction and you say, hey, I think I can divide both those by 2 pretty evenly. And you can. So this is going to reduce to negative 3 divided by 20. And then that's as far as you can reduce that. Okay? All right, let's move to the next one. I'm going to show you a bit of a shortcut or a little different way to do that in a bit, but let's get some more practice here with the positives and negatives. Remember in our example B here, you want to make this mixed fraction into an improper fraction because this 1 is not really the numerator in this whole mixed fraction, you see. So you can't just go 1 times 2 and then 2 times. You got to be real careful there. You could get the wrong answer if you do that. So coincidentally, you could get some of the answers could be right when you do that. But what you want to do is change it to an improper fraction first. And so we do 4 times 2 plus 1 is 9 over 4 times negative 2 over 3, and I'll attach that negative to the top, like in the hint there. So 9 times negative 2 is negative 18. And 4 times 3 is 12. Simple as that, isn't that great? So 9 times negative 2, 4 times 3. And yes, of course, we should simplify this by, I can divide both those by 2. That's what I always think of first. Can you divide them by 2 first? Go ahead and do that. You might be able to keep dividing them by something else. But divide by 2 first, that's pretty easy one to tell. They're both even numbers, so this is negative 9 over 6. And you look at that again and say, can I divide both those by 2? Well, not 9, but if you see this, you can divide both these by 3, right? So you can just keep simplifying, keep reducing until you get right down to the very last step and you can't reduce anymore. So don't feel bad if you have to do that. So this is negative 3 over 2, and that's where you can stop. Negative 3 over 2. And if you were asked to write that in mixed fraction, then of course that would be negative 1 1/2. Okay, because 2 can go into 3 one time, or 3 divided by 2 is 1 whole, and then 1 over 1 left over. So you can write that also as negative 1/2. But improper fractions are generally good. High school improper fractions are great. Now with C here, okay, if you have a whole number times a fraction, best to envision this or view this as this whole number, this 3, can be a fraction over 1. And that's a great way to do that. Because now you just look and say, hey, 3 times 5 over 1 times 8 is 15 over 8. Done. Boom. Okay. Now D says 3 times 5 times what gives us negative 6 over 25. Okay. Well, let's see. 5 times what gives us 25? Well, that's going to be 5. So you probably have a 5 on the bottom. 5 times 5 is 25, right? Now 3 times what is negative 6? 3 times negative 2. So the answer is negative 2 over 5. That's what's missing there. Okay? Now, when you are solving something like this, and some of you may be thinking, can I use division to solve this unknown? You can. I'm going to show you how to divide rational fractions next lesson. So I'm not going to go into that right now, but yes, you can use division here. And you could go negative 6 over 25 divided by 3/5. But I'm going to save that for another lesson, okay? I'll teach you how to do that. But yeah, you can do that. Now, what about this one? Oh, this one might be a bit tricky. Like, what times 3 is 4? Oof. That's where dividing would come in handy, I think. But what you can do is you can say, well, what if this fraction, this 1 over 4, was something different, like an equivalent fraction where I could actually multiply, something times 3 to get something else. So what if we change this to actually 3 over 12? Now I can see that, hey, I can multiply something by 3 to get 12, and that would be a 4. And I haven't changed this. This 3/12 is same as 1/4, right? It's still the same value. So I haven't done anything bad here. And then what times 1 is 3? Well, that would be 3. And look at that, we have an answer. Because, and let me do this over here and show you, 3/4 times 1/3 would be 3 over 12, which would reduce then to 1 over 4. And that's exactly what we had originally. So that's kind of how you can do that. Use equivalent fractions to solve as well. So 3/4 is my answer here. Is that a positive or negative? Positive. Okay. All right, hope you guys are doing well here. We always reduce to lowest terms, but there is an easier way to do this, and instead of waiting till you get to the very end and then having to simplify maybe a fraction with really large numbers, because that gets tricky. There is a way you can do it before you even start multiplying, and that's what this page is all about. So this is supposed to be in step by step. This might be a little confusing to you, but let me walk you through it, okay? In this case, what we see is we have a number like a negative 11 over 7 times negative 21 over 44. Now, by themselves, negative 11 over 7, I can't reduce that fraction, nor can I reduce this one. So up and down, top to bottom, can't reduce it. But I want to show you something. If we know that when we combine this or multiply this, I just multiply the top times the top, and that becomes 1 numerator, and the bottom times the bottom becomes 1 numerator. So this is kind of like one fraction, right? And I'm not going to actually multiply the numbers out yet. I'm just going to show you that you see how, oh, I won't use the dot. Do you see how this is what happens. You multiply top times the top, bottom times the bottom. And so when we multiply, it doesn't matter if we multiply, the first number times the second number, or we switch them around and multiply the second number times the first. It actually doesn't matter. So watch this, what I'm going to do. I'm going to change the order, just the order of the top numbers. Okay? Just the top ones. And now what I want you to look at is to notice that, hey, if this was a fraction all by itself, I could simplify that. And if this was a fraction by itself, I could simplify that too. So really, this is exactly the same as writing two fractions like this, which we can simplify first. All right? This becomes -3, the first one. The second one becomes -1/4, because we divide both by 11. So that's really easy to do. We know that this is +3/4. There's your answer. Now, do you have to do it that way? No, you don't have to do it that way. I just wanted to show you why this little shortcut method that I'm going to show you now works. Because when multiplying two things together, the order doesn't really matter. Okay, so look at this right here, this step right here, all right? I can go ahead and take a number on top and simplify it with any number that's being multiplied on the bottom. And so I can pick one from over here and one from way over here and treat those as a separate fraction themselves. So that's what they did here. -11 and +44 reduces to -1/+4, you see? That is just reduced. And similarly, -21 over here and +7 down over here, those can be reduced. And that gives you a -3 on top and a 1 over here. See that? And now we have our answer already in lowest terms because we did all the work ahead of time. Now let's go back. I want to just go back before I do too much more. I want to go back to, let's say, I could do the first question. Let me do the first question over again. I'm going to do it in red over here. So watch this, -2/5 times 3/8. So if you view it like this, I can actually do my reducing before I even start. Why? Because 2 and 8 can be simplified. 2 divided by 2 is 1, 8 divided by 2 is 4. You see that? So now what I have is negative times 3, that's just -3, and 5 times 4 is 20. And so my simplification is already done for me. And that just disappeared. Okay. I'll just take this moment to just promote my website here. If you go to courses, you can find any course that I've taught in the last number of years here. In this case, you want to look at the Math 9 and just click on that Math 9 page and you can see all the videos for each of the chapters. I'm just working on this right now, so it's not quite complete. But yeah, you can see all this stuff here for every class that I've taught and math and science, and you just go ahead, that's mrmathwell.com. All right, so back to the lesson here. Where were we? All right, so look at these examples here. You see the 8 and the 4 here? I'm looking at this 8 and this 4 here, and yes, I can reduce those. This goes to 2 and this goes to 1. Why? Because I'm dividing both by 4. So remember, 8/2 is the same as 8/4 is the same as 2/1, right? So that's why I can do that. And this is all I do. I just put a little stroke through it and I put the numbers beside. Can 7 and 3 be reduced? No, 7 doesn't divide evenly by 3, so we'll just leave that one alone. What I now have is 2 times -7 on the top, the numerator. And I have 3 times 1 down here. So this is -14/3 done. Okay? And the positive part about this, the good thing about this is that the numbers, you can reduce fractions a little bit easier when the numbers are smaller. So when you multiply two numbers together, you might get a really big, like 50-something or 30-something. And then you have to figure out, oh, how can I reduce that? It's a bit tougher when the numbers are bigger. So you do it when they're smaller, it's easier. So right away, I'm looking at 9 and 3 here. You see that? I can simplify 9/3 to 3/1. And I can also simplify 14 and 16, because I can at least divide both those by 2. So let's try that. That's going to be 7/8. Can I reduce 7/8 any further? Not really. What about 3 and 8? You go ahead and take another look. Can 3 and 8 be, because maybe you missed something. at the beginning. No, 3 and 8 can't be reduced. Can 7 and 1 be reduced anymore? No. So what have I got left? I've got 3 times 7, see? And on the bottom, I've got 8 times 1. So that's 21 over 8. Done deal. See that? Good? All right. Okay, so final challenge here before the assignment here. Final challenge. How could you do this question? How could you find this product? That's a decimal times a fraction. Oof, it's crazy. Yeah, not crazy. Not too bad. What I would do is I would change that decimal into a fraction. Maybe some of you thought of that. And we've got negative 1 over 8. Then what I would do is I would try and simplify as much as I could. So 75 over 100, that can definitely be simplified. So I'm going to make this to be, I'm going to divide those by 25 each. That's the largest number I can divide them by. And so I'm going to do that right away because I know how to do that. So this is going to be 3 out of 4, right? 75 out of 100 is the same as 3 over 4. Now, can I do this? Can I go, hey, 4 and 8, I'm going to simplify those to 2 and 1. Can I do that? The answer is no, I can't do that because the only way you can simplify fractions is when one number's on the top and one's on the bottom. And that number is multiplied by something else. It's got to be a factor on the top and a factor on the bottom. So we can't do this last one, can't do that. Can't simplify it that way. We only look to top number and bottom number. Can't do that, can't simplify these anymore. Okay, so my answer then is going to be negative 3 over 32. And that's your final answer there. Okay, so yeah, that's how you do that. And here is your assignment, page 127 of Pearson's Math Makes Sense, Math 9. And yeah, hope you understand what we talked about there today, multiplying fractions. And there's your assignment. Quickly write that down if you haven't yet. And multiplying rational numbers. This is super important right here. Please remember this. When you have the same sign between any two rationals that you're multiplying, the same side will always equal a positive number. And when the signs are opposite, it always equals a negative number. All right, there you go. Hope that helps.